Hi, my name is Amit, and right now I'm working on a project to create a robot that can navigate an obstacle course by itself and do it faster than the other robots in the competition. Right now, the competition is about a week away. We have the electronics done, we have the software done for simulation-wise, but we need to put it all together. And so today, I'm going to be working on understanding what the LiDAR does, and basically how can we actually get the software part to go into the electronics part. Alrighty, so let's start off with this. What even is a LiDAR? So basically, a LiDAR is a component that sends a laser, and it's basically kind of like a bat's echolocation. It sends out a laser instead, and it records the amount of time it takes for that laser to be sent out and for it to come back. And with that, you basically can calculate the distance since the speed of light is constant. And so why is this useful? Why do we want this? Well, for our car that's going to need to be reacting to obstacles and avoiding obstacles, it's basically going to be able to map out where there's a wall based on how far that distance is being recorded from the laser. And we can pretty much map out what it's seeing, so that way the programming can basically interact with it and say, hey, if there's a wall really close to you, don't run into that, right? And so that's why we need the LiDAR. Okay, so we kind of understand what a LiDAR is. How do we actually get it to work? Because here, let me show you the thing. Look at what we got here. We have the LiDAR, and we only have two cables. Simple, right? We have an Ethernet, right? This could be connected to the Pi, right? That we're gonna be talking to the bot with. But bro, how do I power it? How do I power this thing, bro? But I'm assuming this is like a power, if I were to guess, and this is like how the actual communication happens. But we're gonna do some research. We're gonna figure out how the heck we can actually get this thing to start working, and hopefully we'll be able to implement to our bot very easily. So let's get started on that. Alrighty guys, do I have an update for you? Okay, where did we leave off? Okay, we talked about like what is a LiDAR, but right, this is the LiDAR, and it has two things. It's got this Ethernet cable, and you have these wires. So these wires have different purposes, but essentially, we actually only care about the blue. Is it the light blue? No, we care about the deep blue and the brown, right? Because that's our 12 volt and our ground. So that's what's actually going to be getting the power to the LiDAR. The other things, I'll just read out a quick description here. The light blue resets the IP. The orange basically is if you want to talk to other cameras, it'll send out a pulse every time it's completed a scan, I guess like to line them up. And then the red and the gray wires are for more communication. But that's really just if the Ethernet fails to work, which isn't like a big deal for us. So we can basically simplify this entire thing here to just the deep blue and brown wires, meaning we can pretty much cut the rest of them, cut them pretty low, and then we can bend them, electrical tape them off, similar to what I saw this guy do online. And yeah, that just simplifies it a lot. But what do we do with the power and ground wires? Well, let's get to that. All right, so the power and ground wires, I'm gonna put the power board up on the screen for you guys to see. You see that green terminal there that says 12 volt and ground? Basically, we're gonna put the power blue wire into the 12 volt and the brown ground into the ground. Actually, did I get those switched up? No, I switched them up. The blue into the ground and then the brown into the power. Do not mix those up or else it probably will fry. Unless you want that to happen. That's right. So we got that down. However, how can we make sure that our stuff isn't going to get fried, right? Because, you know, I hear a lot of things about like voltages and things like that if it's not the right voltage, your thing gonna fry. I don't want that to happen. So I did some research on batteries and the battery that we're using. Okay, and so let's go ahead and get started with the main point, the LiDAR, right? So this LiDAR, if you look at the spec sheet, it says 12 volt or 24 volt DC, right? So that means this thing is able to carry like pretty much anything from 12 volt to 24 volt. Let's check our battery. And this thing says 11.1 volt. Are we screwed? What do we do, guys? Do we need a new battery? No, after further research, we do not need a new battery, chat. Why is that? Let's go into a little bit about how LiPo batteries work to show why we can actually use this 11.1 volt battery with our 12 volt minimum required LiDAR. So let's do it. Okay, so basically, I don't know how I'm gonna visualize this for you guys, but right now we can just have a talk, right? So basically, how a LiPo battery works is it's made up of cells, right? It doesn't matter what brand you get it from, or like what kind of LiPo battery you get, they're all the same way. And so you can see, sometimes it'll say the number of cells that are in it, or you'll need to calculate it. But either way, basically each cell has a certain amount of voltage, right? And it's standard for every LiPo battery, and that's the nominal voltage of each cell is 3.7 volts, right? So what is nominal voltage, right? So nominal voltage is basically the voltage that your battery is going to be at like 90% of the time, 80% of the time. It's where the battery will spend most of its life at. Okay, so it spends most of its life at each cell at 3.7 volts. And depending on the amount of cells you have, you just multiply that by 3 to get the nominal voltage. So for example, for this battery here, we have 3 cells, right? So 3 times 3.7, that should give us 11.1, which it does, and that's the listed nominal voltage. Okay, but remember how I said this is the voltage that it's at during the majority of its lifetime. So does that mean that the voltage changes as the battery is at fully charged or dead? Yes, that is exactly what it means actually. So how do you figure out what voltage we're at when we're dead and what voltage we're at when we're fully alive to make sure that we're meeting our voltage requirements? Okay, so here's how we go about this. Okay, you still there? So attention. Look at the match chart. Look at the match chart. All right, cool. All right, pay attention. How do we figure out the maximum voltage that this thing is going to be at and the lowest voltage it's going to be at? All right, so luckily, all LiPo batteries are the same, so it's pretty much easy, I believe. So the max voltage per cell, due to electrochemical laws and rules and stuff, is 4.2 volts. So if you have 3 cells, to find out the maximum voltage, you just multiply this by 4.2. And so the max voltage of our battery, right, which has 3 cells, is going to be 3 times 4.2, which is 12.6 volts. So boom, that is a very good voltage to be had there. Now, when it's dead, it's going to be at 3.3 volts, right, each cell. So how do we figure out how much voltage is going to be at when it's dead? Do the same thing, multiply that voltage by 3, by the number of cells you have. So 3 times 3.3, that's going to give you 9.9 volts. Whoa, that's kind of low. Isn't 9.9 volts kind of low for a LiDAR that is approved for 12 volts? Well, this is where you gotta look closely at the spec sheet, my friends, because if you look at it, actually, it says 12 volt to 24 volt. However, it also says operation range between 10 to 30 volts. So theoretically, that should mean that we are okay that it goes down to that 9.9 volts. It's just so close. And because even if it does go down, let's say it goes down to 9.9 volts or it spikes or something a little bit past that, we aren't going to cause any permanent damage. We'll just cause a error, a LiDAR error. Now, you might be thinking, well, Amit, how do you know it's not going to cause any permanent damage? Well, we can go back to our rules for the electrochemistry rules for LiPo batteries. It says that it only starts getting damage when it's at 3 volts per cell, which we have 3 cells. 3 times 3 is going to be 9 volts, and so that battery is not going to go below 9 volts, and we shouldn't have any damage because it's not going to be reaching anywhere near that. What that means is that since our LiDAR is actually approved with the tolerance of it being from 10 volts to, I think it was like, to 30 volts, right? We're actually more than okay, because the lowest that our battery is going to get is going to be a clean like 9.9 volts. That's like the lowest of lowest. So we don't have to worry. Everything is approved. Here's how the game plan is probably going to be. Once I'm with my team, we have the LiDAR. Ethernet cable is easy. You just plug it into the Pi, and then it can communicate. Then we're gonna have this guy, which we don't need like 90% of the wires here. We're just gonna keep the blue one and the brown one for ground and power. And once we have that, right, we're going to tape down the other one so that way it's not exposed or makes any connection that it shouldn't be. And then we are going to plug in the power and the ground into those terminals on that power board that we had showed there. With that power board there, we are going to make sure that power board is supplying the right power by connecting the battery to that power board. And since the battery we approved to be giving the right amount of voltage needed for this LiDAR within spec, everything should power on nicely and it should be working. All right. And so, yeah, that's pretty much it for my research done today. I like the LiDAR color. It's like my magic card. But anyways, I think hopefully that research was correct. We shall test it in application very soon. And hopefully it doesn't blow up. This LiDAR was a bit expensive on behalf of the team, so we shall see how it goes. But this was a vlog to get some work done. I hope you guys enjoyed. Hope you guys learned something. If you guys have any questions, I'm learning this as well, so put in the comments. We'll both figure out what the heck we're doing. Alrighty guys, so thank you so much for watching and have a great rest of your day. Peace out.